What's up guys and welcome to this video about custom pickers / custom sliders in Jetpack Compose. In this video I'm going to show you how you can build such a birthday picker, but we will build this in a generic way so that you can pass any kind of list with any kind of length and any kind of primitive data type like string or integer, for example. So you can use this picker for your very own needs and you don't have to make a birthday picker. Let me quickly demonstrate you how this picker will work. So we can drag it around, and as you can see, the UI is updating, and we also can't exceed the maximum amount of days here, for example, 31. And I will also show you what happens when we have some kind of a middle thing here, like we don't have exactly 28 and 29, then the picker just jumps to the next value that makes sense. And the same for our months here, and of course for our years. And we can also adjust the picker how much values it should show. Like for the month, we have 5 values, so we only see 5 months completely. And for the days, we have 10 values, so we can also make this picker really flexible. Alright, okay, I'm in an empty Jetpack Compose project here. The only thing I did was to add these two colors, which you can find in my GitHub's repository, which is linked down below, or you can also simply use your own ones. In here, we will straight start with our picker composable. Let's remove the default start first, and then we can define our picker composable, which takes a generic type T. As I already said, we can invoke our picker later with a string list, integer list, double list, or something like this. And we can achieve this by defining this in a generic way. And this picker will take a list, which is also of generic type T, and the compiler can then infer which type is used for T. The next parameter is our show amount parameter, which is of type integer. So how much values we want to show the user on the screen. For our months, we had just 5, and for our days, we had 10. We can set this to 10 by default, but we can also, of course, override this. Then this picker also takes a modifier, which is a default modifier, and we will also pass a picker style of type picker style, which we need to define now. This picker style will be a simple data class, and normally I would put this in a separate file, but for this tutorial, let's do it in the main activity. The picker will have a line color of type color, line length of type float, which is 45 by default, but of course can be overwritten, and then also a text size of type text unit, which is 16 SP by default. Or well, let's also define a default color orange, and then we can invoke our picker style in the parameter list like this. Then we have also onValue changed, which provides our T value, so the current change when we track the picker. And then we are good to go to start with the definitions. First, we need some state values. So we have val list count by remember, and this list count will be mutable state of. We can say list.size. And then we need to import the get and set values. Then we have a correction value by remember, and this correction value depends on our list.size, if it's even or not. So if the list.size modulo 2 is 0, then we know our list is even. Then we can return 1, and else we can return 0. And this correction value is needed when our list is even, and then we can't say that we have our initial value and on the right and on the left side are the same amount of values. And so we need to do a little correction there. You will see this when we come to this point. For our dragging, we have a var drag start at x by remember, which is a mutable state of 0 by default. Then we have also a current drag x by remember, and we are just interested in the x values here because we can just drag this around on a horizontal line. And this will be also mutable state of 0 by default, and we have also an old x value so that we can compare the new dragged x and the old x to calculate how far the user actually tracked. Now things will get interesting. We will start with drawing our picker, and we will do this in a canvas scope. So we will import canvas, and then we get a draw scope where we can draw some different rectangles and lines and all that things. First of all, we need to define a top of the canvas, which is 0f, and a bottom, which will be our size.height. To draw the background rectangle, which goes really far to the left and the right, so that we can display all the array numbers and all the array texts on it, we need the native canvas, because we also want to apply a little shadow here. And the shadow is only available in this native canvas, so we can say draw context.canvas.native-canvas.apply, and then we get this native canvas scope. In here we can then draw a rect, and this takes a rect, and we need to define now how far this rect should go to the left and the right. And since we could have huge arrays, we want to go really far to the left, which we can't even see as the normal user. So we will say -2000. You could also make this depending on your array size, but yeah, I think 2000 is fine for now. And for the top, we say top to int. And for the right, we also have the same principle with this 2000, but we first need to add the size.width, because we start at the left and then we add the width, then we are at the right, and then we add 2000. And for the bot, we say bot to int. Alpha is equal to 0.8f, and then to RGB. And oh, I missed to import the white color, so let's go to colors and import this white color, or choose another color, and then we can import it like this. And then we also get access to this 2RGB, and then we set our shadow layer. The shadow layer will have a radius of 30f. We can pass 0f for dx and dy, and for the color we say color.rgb 50, 0, 0, and 0. And then we need to make sure that we have this android.graphics.color like this. And yeah, this can be a little bit confusing, because we have the compose color and the old ones. And so make sure that you add this package name before, because we used the compose color earlier in this project. And the same thing for our rect here, it's the compose one, and yeah, just the wrong import. Be a little careful with that. And well, where is here, this one? We need to remove this and then import the android.graphics one, and then the error will be gone. Now we have defined our background rectangle where everything gets drawn on, and we can loop over our array now and draw each item and the corresponding little line above the item. And before, we need a space for each item value, which says how much space we have actually for the item. And this depends on our size.width, our canvas width, and our show amount. So for example, we have a show amount of 10. So we want to show 10 different items to the user. And then these 10 different items need to share the width of the canvas. Now we can loop over our array for I in 0 until our list count. And first we need the current x value, where we should start drawing. Well, current x is equal to I multiplied with space for each item minus current track x minus list count minus 1 plus correction value, and let me make a little bit space so that you can see it, minus show amount divided by 2 multiplied with space for each item. Okay, what the heck does this mean? Alright, I made a little bit space and broke it up in the next line so that you can see the whole calculation. And maybe you are not interested in and just skip it, but let me quickly explain it. We have our I here, which is multiplied with the space for each item. So our I goes from 0 to our list count minus 1. And this means we draw our different items, the lines and the texts, step by step, and we have a gap between them. So I 0 multiplied with space for each item means 0, and then we subtract all this stuff, so we draw at the very left. And then we have I is equal to 1, so we add 1 times the space for each item, so it's almost at the left, but not at the very left. And this minus current track x is not important for now, because this is 0 anyway, and we don't care about tracking right now. And this calculation here means that we have the same amount on the left and the same amount on the right of our centered value. And yeah, we have this correction value here as well because we need to treat odd and even array sizes a little bit differently, because in an odd case we have on the left and the right the same amount of values, and if the array size is evener, then we need to display, for example, when we have an array of 20, then we have one centered value, which is the 10th one, or the number 10, for example. Then we have 9 on the left and 10 values on the right, because we can't split it evenly. And yeah, this is basically what this means. And yeah, after that we have our line start, which is an offset. For our x we pass our current x and import offset, and for the y value we simply say 0f, because we start at the top of our canvas, because the canvas is kind of inverted and the y start is at the top. Then we have line end is equal to offset, and for the x value we pass current x as well, and for the y we have our style dot line length. So our style is defined down here, so the line length of 45 will be this y value, and so we have a little line from the top of the canvas down to the line length. Then we can draw this line with draw line. For the color we say style dot line color. For the stroke width we say 1.5 dot dp dot 2 pixel, import dp. For the start we have the line start, and for the end we have the line end. Then we need to draw on the native canvas one more time, because I think we can just draw text there. I'm not sure about the Compose canvas. If you know something, then let me please know, but I'm definitely sure that it works on the native canvas. For the y value, where to draw the text, we say style.line length, and then we also want to pass a little bit of space between the line and the text, so we say 5 dp 2 pixel plus style.textSize.2 pixel, because we also need to keep in mind our text size, or need to take care of that. Then we can draw the text, draw text, lists at the position of I to string. So our list item at the position of I will be drawn. For the x value we pass our current x, for the y value the calculated y, and then we also have a paint and apply the text size, which is style.textSize.2 pixel. The text align will be paint.align.center, and we also make it a little bit bold with the is bold text property. And I think this should be it for drawing our different values of the picker. Let's try this out. Let's go to our main activity up here and just invoke this picker. Inside our set content, we will have a box with a modifier and import box, and the background will be gray, and the modifier will fill the max size. And for the box, we have a content alignment, alignment.center, and then we can invoke the picker. For the list, we pass an array from 1 to 31 and say to list, and then integer will be our generic type t of our picker here, and the compiler will infer that. And we also have the on value changed here, which is not important for now because we currently don't have dragging logic. Then we also need to pass a modifier which fills the max width, and the height of this modifier will be set to 60 dp. And then we can start this. All right, cool. This looks fine so far. We can also check if we change the show amount to 15, for example, and start this again, then we should see 15 different values. Yeah, as you can see, this works also fine. And yeah, we are very flexible now. And let's define our dragging logic in our canvas modifier. For that, we need to apply the pointer input modifier. And in here, we can then say detect drag gestures. And we need to define the onDrag start, the onDrag end, and the onDrag method. And this will provide us a change and a change amount, which we don't need. Let's start with the easy ones, on track start and on track. For on track start, we simply say track started x is equal to it.x. The offset we get provided here, we can also write it like this, offset.x, and we get an error because our state here is integer. Yeah, we need to change the state to float values, of course. Then in on track, we get the change x. Again, we are only interested in the x changing values because the user should only or can only track this horizontally. We get the change x from change.positioner.x. Then we have a new x, which is equal to old x plus track started x minus our change x. After that, we need the space for each item to calculate then if the user's tracking is actually within the range. You will see how this works. We will say, well, space per item is equal to size.width divided by show amount. I know we had this calculation down below in the canvas draw section, but yeah, I will just make this value here again. Feel free to make this more globally, that you can use it from everywhere. And then we can check if the user's tracking is actually within the range of the values. So if the user did not exceed the maximum value or went down below the minimum value. We can say current track x is equal to new x dot coursed in. I hope I spelled that right. The minimum value will be minus list count divided by 2f multiplied with our space per item. The maximum value will be our list count divided by 2f multiplied with our space per item as well. So we will have an even look at the left and the right side from the center of our tracking section. And this course in function, we can have a look at the return documentation here. It returns if it's within this range, or if it exceeds, or if it's down below, then it just returns this minimum and maximum value. So the tracking really stops at the minimum and maximum value. Then we need the corresponding index of our list item so that we can invoke the onValueChanged function and provide the corresponding value inside our array where the user tracked to. We can get this index from list count divided by 2f plus current track x divided by our space per item, and then we can map this to int. And this means that we have as a basis half of our list count, and then we add the current track x, which can be negative or positive, divided by the space per item. And I think we should also put parentheses around this, because this can be also floating value if the list count is not even. And then we get the corresponding index, and we can simply say onValueChanged list and pass our calculated index. Okay, fine. Now the last thing that's left is our onTrack function here, which will be a little bit more complicated, but I think this should be fine. It's mostly about the rounding things. If the user tracks between two items, that the tracking logic, that the slider goes to the nearest value when it is between two values. Okay. First of all, we again need our val space per item. Well, I could really make this a constant, but never mind. And then we can get the rest of our tracking. And we get this from our current track x modulo space per item. If the user exactly tracks on an item, then this rest will be 0. But if it's a little bit more left or a little bit more on the right, then this rest has a specific value, and we can check on this value and do some corresponding logic to it. We will say, well, round up is equal to the absolute amount of our rest divided by space per item, and round this to an integer and check if this is equal to 1. Because if this absolute amount here is 0.5 or higher, then we know that we are closer on the right. If this is less than 0.5, then this round to int would make this to 0, and then we would know we are closer at the left. And this equal check here just makes this round up a nice Boolean value. Then we can create a new x value called new x is equal to if round up, and then we need to check some different cases. And in here, in this round up case, we have another case. If rest is less than 0, then we say current dragx plus the absolute amount of rest minus our space per item. If this is not the case, then we say current dragx minus rest plus space per item. And if we should not round up, if we should round down, then we also need to check if rest is less than 0. And then we say current dragx plus the absolute amount of rest, and else we say current dragx minus rest, like this. In case you're asking yourself what the heck this shit is, these are the 4 cases that can occur. The user can drag on the left, and when he drags on the left, then there are 2 other cases. If the dragging is closer to the right item or to the left item. And then the user can also drag on the right. And there are also 2 cases. The one case if it's closer to the left, the other case if it's closer to the right. And yeah, this is basically this 4 possibilities. And down here we can just copy this logic, I think, and paste it up here like this. And then our dragging logic should be almost it, I think. The only thing that's left is to set our old x to our current drag x, and then we can try this out. So, okay, this does not look good. Okay, I found a mistake, and I also found another one. I forgot to add this minus correction value, because in a case, if we have an even-sized array, then we need to subtract from this list count 1, because we will have more items on the left than on the right when we have a look at our initial center value. And yeah, this is because we need to subtract this correction value, which is 1 in case if we have an even-sized array. But the crash actually came from this index calculation, and I wrote it like this with this floating division here, but we strictly want to have this list count divided by 2, even if it's an odd array, because then we will just cut the comma separated value. And if we write it like this, then we are always on the safe side, so that this index does not exceed the list size. And yeah, we can try it out now, and don't forget to also change this up here. And now we can see that the dragging works fine, and we can't exceed the 31, and also on the other side we can't go down below the 1. Okay, all right, this is it for our picker. Let's put everything together and invoke 3 of them pickers with the year and the month as well, and also the rectangle between, around the current picked value. And up here in our main screen, we can define 3 different state var. So the day by remember, mutable state of, the default value will be set to 16, because I know this is the centered value. If we pass our 1 to 31 day array, then the month by remember will be mutable state of July, and the year by remember will be mutable state of 1980. In our box we will have a column which takes a modifier, which we will let the default modifier. We won't apply any additional stuff here. We have a vertical arrangement, which will be arrangement.spaced by 20 dp, and a horizontal alignment, aligned.center horizontally. And in this column we can then put our picker for the days, and for the value we can then say day is equal to it.toInt, because we get the day provided here inside this lambda block. Then we can copy this picker and paste it below, and this time for the list I will simply copy and paste this here. You can find this from my GitHub repository, but I think I don't need to write off all this once here. And then we can copy this picker one more time again, and this time we will have a range. List will be equal to 1950 to 2010, for example. and then we will map this to a list, and then we can check how this looks. And yeah, I think this looks good so far. We also need to adjust the different amount which the user should see. And the show amount for the month will be set to 5. For the year, be 8, I think. And then we can start this again. And yeah, I think this looks fine. And we also need to change the on value changed here. For the year, we will say year is equal to it.toString. And for our month, we can say month is equal to it. And the last thing that's left is our rectangle and our text field, which shows the corresponding date which the user selected. For the text, we will say date of birth, our month, day, and the year. And then we pass a modifier dot align. Because we are inside a box, we can apply this alignment modifier bottom center, and the padding will be set to bottom 130 dp. Well, it doesn't matter what simple UI is. For the color, we will say color.white. The font weight will be set to font weight.bold, and the font size will be 28 SP. And the last thing that's left is our composable, the rectangle, which will be really quick. This will be a composable called rectangle, which takes a modifier, and this is the default modifier. If no one is passed, then we will draw on canvas. This canvas takes the modifier, and we can open the canvas draw scope. And in here we can draw the rounded rect. For the size, we can pass size.width and size.height, so the canvas size. For the style, we will pass the stroke. The width will be 10f, and the join will be stroke join.round. I'm not really sure if this has an effect inside the draw rounded rect, but let's pass it to be sure. The color will be orange, and the corner radius will be corner radius 25f and 25f. And then we only need to invoke the rectangle, and then we can try it again. And I think this should be it then. Very long video. Modifier is equal to modifier. The height will be 260 dp, and the width will be 50 dp. Play around with these values and adjust this to your own projects. Alright, okay, this looks very good. I think everything is working so far. And yeah, sorry for the long video about such a little UI element. I underestimated it a little bit, and sometimes I'm thinking, well, don't explain it and just skip over it. Nobody is interested in this, but sometimes I can't. Okay, alright, this was it for this video. I hope you enjoyed it and you can apply this cool composable in your own project, and we will see us in the next video.